Hello, welcome to my channel. So today we are going to discuss a kinematic problem related to College Physics 1. So you can see the problem now. So let's go ahead and read the question. Robin roller skates down a marked sidewalk, was observed to be at the following position at the time listed below. So you have a graph here, a table actually, giving time in seconds and x position in meters. So generate a position versus time graph. So that's what they're asking. So let's try to generate that graph. So you can see at 0 seconds, the position is 10 meters. So that's over there. Then at 1 seconds, it's around 12. So somewhere over here. And then at 2 seconds, it's 14. Over here, sorry, wrong position. It should be somewhere over here. And then at 3 seconds, there's no position. And then it says 5 seconds, it's at 20. And then at 8 seconds, again, it's at 20. So that's 8 seconds, it's at 20. And then lastly, at 10 seconds, the position is 10 meters. Okay, so then we can kind of connect these these points. So I'm going to use a straight line like that. Okay, so this is the position versus time graph. Okay, so then the next part in the question, part 2, what was Robin's final displacement? So displacement is defined as delta x equals final position minus the initial position. Let's look at the final position. For this time period from 0 to 10, the final position is plus 10 meters. Minus, what is the initial position? Again, that's plus 10 meters. So then you can see the final displacement is 0 meters. That's the final displacement. Then what was Robin's position at 3 seconds? So let's go back to the graph. So 3 seconds. At 3 seconds, what's the position? What's Robin's position? So it's somewhere here. So we can see like it's definitely between 15 and 17.2. 15 and 17.2. But how exactly can we figure that out? So that's where we are going to use the slope of this straight line. Okay, we are going to use the slope of this straight line. So let's consider this position as x. Okay, so then at 3 seconds, let's assume that the position is x, and then we need to find this x value. And then since it's a straight line, it's going to have the same slope. So we need like 2 more points to figure out the x value from the slope. So this point, as you know, that is 0, 10. And then let's take another point. I'm going to take this point. So that's going to be 2, 14. So using these 3 points, we can find rise over run, which is the slope. Since it's a straight line, the rise over run is going to be the same in each case. So that's what I'm going to use. Okay. So I'm going to first consider the 3, x and 0, 10 points. So rise over run, that is the change in the y value divided by the change in the x value. So change in the y value is like this. And the change in the x value that is 3 minus 0. And this is equal to, again, the same slope. So I'm going to then consider 2, 14 and 0, 10 points. So 14 minus 10 divided by 2 minus 0. Okay, so then we can further simplify this. X minus 10 divided by 3 equals, there's a 4 in the numerator, then there's a 2 in the denominator, so that's a 2. And then you can see we can simplify this. X minus 10, so that's this one. 3 times 2, okay, so that's, I'll write it like this, 3 equals 2, and then you can cross multiply, right? So x minus 10 equals 6, and then you can see x is equal to plus 16, plus 16. So at 3 seconds, the position, Robin's position is plus 16 meters, plus 16 meters. And that makes sense. If you look at the graph over here, that's like between 15 and 17.5. So 16 is a reasonable value. So that's right. Then number 4, what was Robin's average velocity for the first 5 seconds? Okay, so for the first 5 seconds, so that means from this point to this point, so you can see there's a slope, it's a straight line. So there's going to be a constant. If the slope is the same from 0 to 5 seconds, which is the case what we see here, then same slope means same velocity. So we'll go ahead and find the average velocity. Let's look at the total displacement. Total displacement is 20 minus 10, right? Final position minus the initial position. So I'll write average velocity is equal to change in position divided by change in time. The change in position is 20 minus 10, 20 minus 10. And these are positive values. Divided by, what is the time difference? 5 seconds minus 0. 5 minus 0. So then you can see plus 10 divided by 5, which is plus 2 meters per second. So the average velocity for the first 5 seconds for this person, Robin, is plus 2 meters per second. The plus sign tells us that the object is moving in the positive direction. That's what it tells us. Then the fifth one, describe Robin's motion from 0 to 10 seconds. So 0 to 10 seconds is the entire duration for the motion. So we can break it down into 3 segments. As you can see clearly from the position versus time graph, there are 3 segments. So I'm going to consider from 0 to 5 seconds. So for the first stage, as the first stage, I'm going to consider 0 to 5 seconds, constant average velocity. Constant average velocity of 2 meters per second in the positive direction. So what do I mean by that? The object is moving with a constant velocity 2 meters per second in the positive direction between 0 and 5 seconds. Then the second part, 5 seconds to 8 seconds. What do you think? 5 seconds to 8 seconds, the object maintains the same position, right? If you see, it's 20 meters, 20 meters, 20 meters. So that means the object is at rest. Object is at rest. That's what it means. Then the last one, 8 seconds to 10 seconds. 8 seconds to 10 seconds, there's again a slope, a constant slope. Okay, there's a constant slope. So then what happens is it's a negative slope. So the object is going to turn around and comes towards the starting point. That's what's going to happen. So there's going to be a velocity in the negative direction, but again, that's a constant velocity. So there's going to be a constant average velocity and then we can go ahead and find that velocity. How do we find the velocity? Again, we have to look at the slope, right? So we have only 2 points. So let's look at the slope using these 2 points. So that point is 8, 20. And then this point is 10, 10, right? So then the slope is going to be final minus the initial always. So the vertical difference rise. So the final is like 10 minus 20 divided by 10 minus 8. So then you have minus 10 divided by 2 minus 5 meters per second. So from 8 seconds to 10 seconds, the object is moving with a constant average velocity of minus 5 meters per second. Minus 5 meters per second. Or you could say, instead of like putting the minus sign to be consistent with what I have done from 0 to 5 seconds, you can say 5 meters in the negative direction. Along the negative direction or in the negative direction. So that's how we describe Robin's motion from 0 to 10 seconds. It is divided into 3 segments, 0 to 5 seconds, 5 seconds to 8 seconds, and 8 seconds to 10 seconds. Okay, so let's look at problem number 6. If Robin continues at the same average velocity obtained during 8 to 10 seconds, we know that is minus 5 meters per second. What can we expect their position to be at 12 seconds? Okay, so we know the average velocity for between 8 and 10 seconds, that part. So that is minus 5 meters per second. And that is equal to change in position over change in time. Okay, so we want to find the position at 12 seconds. So that is beyond the time period that we are analyzing here in this problem, which is 0 to 10 seconds. So let's assume that at 12 seconds, the position is x. So x when it is 12 seconds. And then we also know the final point, right, for our motion. At 10 seconds, it's 10 meters away from the starting point. So I'm going to do this. I'm going to like 10 seconds. So that's the change in the position, and then minus change in the time. And that's how we get that. So here, if we simplify this, we get x minus 10 divided by 2. So then let's simplify this further. Minus 5 equals x minus 10 divided by 2. We'll get minus 5 times 2 is minus 10 equals x minus 10. And then you can easily see minus 10 and minus 10 cancels out. So x is going to be 0 meters. So what happens is at 12 seconds, if Robin maintains the same average velocity of minus 5 meters per second, at 12 seconds, he will be at the origin. He will be at 0 meters origin. So that's that answer. And 7, what we are doing is we are trying to construct velocity versus time graph for Robin's motion from 0 to 10 seconds. We know that in problem number 5, we divided the motion into 3 segments, 0 to 5 seconds plus 2 meters per second constant velocity. So I'm going to say 0 to 5 meters. So let's say that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so from 0 to 5 seconds, constant speed, constant velocity in the positive direction. Sorry. So it's going to be like that. And then I'll put plus 2 meters per second, constant 2 meters per second in the positive direction. Then 5 to 8 seconds, Robin is at rest. He's not moving. Okay, so then 0 velocity. Then from 8 to 10 seconds, negative 5 meters per second, again constant velocity. So 1, 2, 3, 4, 5. It's in the opposite direction. So that's why I'm putting like negative 5 meters per second. So that's going to be the motion. So this is the velocity versus time graph for Robin's motion. Okay. And then the last one, problem number 8, construct an acceleration versus time graph for Robin's motion from 0 to 10 seconds. What do you think? What do you think? Looking at the velocity versus time graph, can you describe what the acceleration is going to look like? You can see we have 2 intervals where the object is moving with a constant velocity. There's no change in the velocity, it's constant velocity. And then there's one section where there's 0 velocity. So for the entire duration, what you have is 0 velocity. So the object has no acceleration for the entire duration of the time. So from 0 to 10 seconds, you have to draw a line like that. So it's 0 to 10 seconds, so up to here. Okay, so I'll put A equals 0. Okay, and that's how you do this problem. So this is a very nice kinematic problem for a college physics class. We constructed the position versus time graph. Then we figured out the final displacement. Then by looking at the slope for a position versus time graph, which is the average velocity, we were able to figure out the final position after a certain time. We were able to figure out the average velocities. Then we described the entire motion. And then we constructed velocity versus time graphs, looking at position versus time graph, and then acceleration versus time graph. So that's how you do this problem. Thank you very much for watching my video, and please go ahead and subscribe to my channel. I'll be posting more videos like this in the future. Thank you again. Bye.